Welcome! Today we do trig substitution. It allows us to integrate things like this. We write x as sinus u. Usually we would start with u is equal to arc sine x, but we write it like this. It's easier. And then we have cosine u du. And what is nice is that expressions like this become simple. Like the square root of 1 minus x squared is the square root of 1 minus sinus square u, which is equal to, as you know from Pythagoras, this is just cosine u. So what we have is, if we make this substitution, let's put that in the cloud here. If we make this substitution, we have the integral and this square root, that's the cosine u comes in the back. The dx will be replaced with cosine u du. So we have cosine u du over cosine u. That goes away, so that's the integral 1 du. That's equal to u. And we all know by back substitution that this is now arc sine of x plus c. So of course we knew that integral already. We have already differentiated the arc sine and we got this expression. But now we have derived it from, you know, we would not, if we would not know what this is, we have derived it. Let's just look at another example. Let's integrate the square root of 1 minus x squared. We do the same thing. Actually, I can leave this cloud already, and then what we have is the integral, and then the square root becomes just cosine u, and then the dx also cosine u, cosine square u du, and with the double angle formula, we get this is equal to 1 plus cosine 2u half, which is no problem to integrate. This is u half plus sinus 2u over 4. And then we can back substitute. This is u is equal to arc sine x, so this is arc sine x half plus, and then let's just leave it like that, sinus of arc sine x times 2 over 4 plus c. So that's the idea. And you see, it's not much different than substitution. It's actually just a special case of substitution, but we are doing it in a different order. Kind of, we write x as a trigonometric function. We don't write u is equal to something else. Okay, let's compute the area of this disk. We have already done that in the area part. So we integrate from minus 2 to 2. And then we have a function above, right, which we function above. So because x squared plus y squared is equal to 4, we can solve for y. So this is y. This is a square root of 4 minus x squared. That's y. And on the bottom part we have a similar thing. We have a minus the square root of 4 minus x squared. So we know how to get the area here. It's the upper function minus the lower function. So this is 2 times the square root of 4 minus x squared dx. Now we don't have a 1 minus x squared. In order that this works with a substitution, what I'm doing, I'm writing that x is equal to 2 times sinus u. You see, because then 4 minus x squared is equal to 2 times cosine u. Right, it's the 4 minus 4 sine square u. We can take the 4 out under the square root, and so the dx is equal to cosine u du. So that's our substitution, which we do, and then we can take the 2 out. So from minus 2 to 2. There is a way to do that a little bit more more efficient that we also kind of directly convert the bounds. Let's just do that also. So what we have is 2 times sinus u. That's our x. If this is equal to 2, and we look at the sine function, let's just look at the picture here. If you have the sine function, so this is the 2 times sinus u function. So this is u, and this is x, and this is then 2 minus 2. So if you go from minus 2 to 2, that's the same thing then in u going from minus pi half to pi half. So what we can do is also substitute the bound, and then what we get is the integral from minus pi half to pi half, minus pi half to pi half, and then we do all the substitutions. So we have 2 times, and then we see that this is equal to cosine 2 cosine u this is 2 cosine u, and then the dx becomes also a 2 cosine u du. So what we have is an 8, actually we have an 8 here. So this is 8 times the integral from minus pi half to pi half of cosine square u du. And again we do the double angle formula, minus pi half to pi half, and then the cosine square u becomes 1 plus cosine 2 u half. So that's equal to u half, 8 times u half, and then plus sinus 2u fourth, evaluated from minus pi half to pi half. So this becomes 0 when we put pi half in. We get sinus pi, and also minus pi minus sinus minus pi is also 0. So the only thing which survives is the pi half plus pi half. So this is 8 times 2 times, so this is 8 times pi. So this is what we have is pi half. So this is pi half. So this is 4 pi. And we know this is actually right. This is r square pi in general. You could everywhere replace the 4 with r square and the 2 with r. So let me just indicate that you can replace this with r and this with r square, and everything would go through and we would get an r square here. I invite you to do that on your own. But that's the area of the circle, and in the case when we did that originally, I actually had to give you the integral. Now we can just do it. There is a general recipe for integrating rational trigonometric functions. And let me just write you down how that works. So we can transform an expression using trigonometric function into an expression without trigonometric function. And so what we do is, let's just write this down. What we take is x is equal to tangent u half and dx, and let me just write that down. Dx becomes then du, 2 du over 1 plus u square, and sinus x becomes 2u over 1 plus u square, and cosine x becomes 1 plus u square, 1 minus u square over 1 plus u square. So this is a general recipe. If you want to verify this, that this works, so you differentiate, and you can double check all these identities. I'm not doing that here, but I just show you how you can use this recipe to integrate things. So what we can do is, for example, we can integrate the 1 over cosine x dx. So show you how to do that. So we use this recipe here and we just replace everything with the expressions which we have. The dx are replaced with, so what we get, the dx are replaced with 2 du over 1 plus u square, and the 1 over cosine x are replaced with 1 plus u square over 1 minus u square. And you see that that cancels away, so we get the integral 2 over 1 minus u squared du. Now we have replaced this rational function in trigonometric function into a rational function involving u, and now we know how to do that with partial fractions. We did that last time, so this is actually just, we can split this up into the integral of 1 over 1 minus u plus 1 over 1 plus u. And so this is a log of 1 minus u with a negative sign plus log 1 plus u plus c. And now we can, if you want, back substitute. So this is equal to minus the log. U is equal to arctan of x times 2. 1 minus, and then plus log 1 plus 2 times arc tan of x plus c. So that's this recipe. Let's look at another example. I want to integrate 1 over sinus x. I leave this recipe, so we treasure it. Maybe we can put it into a golden frame. So this is, you don't have to memorize this, but that's just it's a general recipe. The computer can do any of trigonometric expressions. Rational trigonometric expressions can be dealt with this magic. This is the magic general recipe. Let's just see what happens here with the sinus x, 1 over sinus x. So what we get is, if we do the substitution, the dx, we look it up here, so this is 2 du over 1 plus u square. And then the sinus x becomes 1 plus u square, 1 over sinus x becomes 1 plus u square, and then divided by 2u. Oh, that becomes really nice. See, that goes away, so that's just the integral 1 over u du. And what we get is, of course, that's just the log of, the natural log of u plus c. And now we just can replace back the u. So this is the log. And then we take the arc, 2 times the arc tan of x plus c. So that's the general method. The last problem we are going to look at is very classical. The Greeks were interested in moon-shaped areas like this. Connection with the quadrature of the circle, etc. So we can compute this area using trig substitution. But it reminds me, this shape actually, it doesn't remind me so much of moons, but of a raclette. Raclette is a Swiss cheese. We had just on last weekend, we had that, you put it on the fire and you melt it, and then you scrape it off and you eat it. It's wonderful. And this shape here, we actually compute this shape here, shape of a raclette cheese. Let me just draw that a little bit bigger here. So what we have here is this shape, square root of 3, 1, and so this is actually, let me just draw both parts nevertheless. So this is then 2. So what we are computing is the area of this region here, two raclettes together. So we already have computed areas before, so we just have to have the function here above. And let me just write that down. So what we have is here x squared plus y plus 1 square is equal to 4. And this is equal to x squared plus y minus, no, this is minus 1 here, and this is plus 1 square is equal to 4. So we can solve here for y and say y is equal to the square root of 4 minus x squared and then minus 1. So that's what we have here, and we have to compute the area under the curve. So what we have is the integral, and then we go from minus square root of 3 to square root of 3. And then we take 2 times the square root of 4 minus x squared minus 1 dx. And so there is one part which is no problem. The second part is no problem. But let's just do that with a trig substitution. So we have already done that. X is equal to, we take 2 times sinus u. Dx is equal to 2 times cosine u du. So, and then the square root of 4 minus x squared, we have done that before. That's just also 2 times cosine u. 4 minus 4 sine square u is 4 times 1 minus sine square u is 4 cosine square u. We take the square root. So that's the substitution we are using here. And let me also take the bound. So this is the function here. The function is 2 times sinus u. This is u. This is x. And we have to go from minus square root of 3 to square root of 3. So this is a minus square root of 3 to square root of 3. So this is here minus square root of 3 to square root of 3. So we have to see the angle here. And the angle is actually then just minus pi third to pi third. So this is minus pi third, and this is pi third. So what we can do is we have just 2 times minus pi third to pi third, and then we have to substitute all these in here. So this is 4 cosine square u, and then minus 1 here. I'm actually take that separate, and I just take minus, and then what we have is 2 times what we have is 4 times square root of 3. So that was the y is, yes, I think that's right, minus 4 times square root of 3, that's right. And we can use, here we can take the double angle formula. So this is 8 times minus square root, minus pi third to pi third of 1 plus cosine 2u half du minus 4 times square root of 3. And if we integrate that, so we get, let me just take that out. Let me leave it for now, and then we have u plus sinus 2u fourth evaluated from minus pi third to pi third minus 4 square root of 3. And if we plug that in, we get square root of 3 here. So this is 2 times square root of 3. So this is 8 times pi over 3. If we plug that in here with sinus 2u half, sinus 2u, if you take sinus of 2 pi third, that's square root of 3/2. So what we get is minus, and then we have a 2 here, so this is minus 2 times square root of 3 plus 2 times square root of 3 minus 4 times square root of 3. So this is 8 pi third minus 2 times square root of 3. So that's this area here, and there is an elementary way to compute this also. We can do that just by looking at just do that in an elementary way. So what we can do is we can just look at this sector here and divide that. Let me just shade that. Let's call this area B here. Actually, let me just take the whole thing as B. And we have also an area which is a triangle. So we have here that one here, which let's just call this A. And so what we have is the area which we have of the cheese, right? So let's call this C here. The area of the cheese is the cheese area is equal to 2 times, and then we take B minus A. So let's compute the area B here. So what is B? B is, this is 120 degrees, this is 2 pi third. And so this is just a third of a whole circle of area 4 pi. This is 4 pi third. And A is this triangle. This is 2/3 of a circle of radius. And the A is a triangle which has height 1, and this is square root of 3. So the area of this triangle is just square root of 3. This is the area of a triangle. And so if we take B minus A, 2 times B minus A is exactly that. So this is equal to 8 pi third minus 2 times square root of 3. So there's also an elementary way to compute this area of the cheese. Cheese!